Here we're going to attempt another dimensional analysis problem. This one's a little unique in the fact that we're going to convert a density. I have 4.2 decagrams per liter, and I want to convert it into a density of grams per milliliter. Now this is interesting because the unit already has like a numerator and a denominator to it. All the problems we've done so far, we just put our given, when we write down our given, we write something in the numerator only, and we leave the denominator position empty. So you'll usually see I have a line, and then I have a whole bunch of vertical lines here that I'm putting things into for conversion factors, and usually up here in this first spot up here in the numerator, I just write one thing. Well, in this case, I have a unit and densities like this, where it has a numerator and a denominator unit. Velocity is another one that's kind of like that. So that's dimensional analysis takes care of that pretty easily. All I need to do is I'll write 4.2 decagrams on the top, and then the line right here, this line right here is really this line right here. So it's the same thing, and I'll put 4.2 decagrams per every 1 liter. I don't really need to write the 1. I'll just put a liter on the bottom. So you'll see that I have the density written the way it's supposed to be written, 4.2 decagrams per liter. So what I want here is I want grams to be the unit on the top, not decagrams. And on the bottom, I want the unit milliliters, not liters. So although this might seem confusing at first, it's really fairly straightforward, just like normal dimensional analysis types problems. We just need to decide which one you want to do first. You want to do the top, you want to do the decagrams, or do you want to do the liters on the bottom? And it doesn't really matter. We can pick either one. If you want to, we'll go ahead and pick the liters first. Let's convert liters on the bottom. Instead of liters on the bottom, I want milliliters on the bottom. So what do I do in this first conversion factor? Well, I need to get rid of liters on the bottom. So how do I get rid of that? Well, I put a unit of liters on the top. See, it's just a little reverse, but it's still the same idea. On the top, I'll put liters. On the bottom, I will put milliliters, because that's exactly where I'm trying to go, and I happen to know a conversion factor between liters and milliliters. In every 1 liter, there are 1,000 milliliters. And liters, you'll see, will cancel off, and milliliters, I'll circle that because that's the unit I wanted, and I wanted it on the bottom. So I have that exactly where I want it. So now I can go back and I can work on the top unit of decagrams. And I just go and I find my next available conversion factor location, which of course is right in this spot here. And I don't want decagrams on the top, I want grams. So I'm going to put decagrams on the bottom so that it will cancel out, like this. And on the top, I'm going to put grams, because I know a conversion factor between grams and decagrams. In 1 decagram, deca, DA, means 10. So 1 decagram means 10 grams. And on the top, I can say, aha, I found you. I wanted grams on the top. So now if you look at your units, you have grams on the top and milliliters on the bottom. Those are the only units, the dimensions that are left. And that's exactly the way that you needed them here, grams over milliliters. So all I have to do is my math. I can multiply the top numbers and divide by the bottom numbers. So I'm going to take 4.2 times 10 and then divide by 1,000. And that will give me 0.042 grams per milliliter. That's what my calculator gives me. Now, is that the right answer? Well, in my given, I had 2 sig figs. 4.2 is 2 sig figs. Do I have to worry about any sig figs for this? No, that's a metric definition. What about this one? Again, that's a metric definition. So I don't have to worry about sig figs here. I can just go with however many there were in my given, and there were 2. Well, in my answer right here, there's also 2.042. Those are significant, and so that would be my answer. So that's how you can do a dimensional analysis problem when you have some units that are kind of already have a numerator and a denominator aspect to them.